I'm going to be here talking about tuples, which is another compound data type in Python. So a tuple is very similar to a list in its structure, um, in many of its uses, not all. And in fact, it kind of differs from a list mostly in um, convention, really how it's used. So it's similar to a list in that it's a sequence of values that do not have to be of the same type. It's not like a string where they have to be a single character. But unlike a list, tuples are immutable, like strings, in that single elements of tuples cannot be modified or swapped out as they can be in lists. Syntax-wise, a tuple is defined by a series of values separated by commas. Often you'll see parentheses or rounded parentheses enclosing those. So tuple equals a sequence of 5 single character letters, A, B, C, D, E, enclosed in parentheses separated by commas, if you tried to assign a capital A value to this 0 index position, it would throw an error because tuples are, by design, immutable. So tuples, the syntax is a little bit trickier than a list, just because parentheses are fairly commonly used elsewhere in Python. So if you want to create a tuple with just a single value, here the string letter A, you need to put a comma after it. If you don't do that, what you get is just a single letter string value being assigned to your variable name. So here it's T2, up here it's T1. T1 is a type tuple, T2 is not a string. For lists, you don't have this problem. You just use the square brackets. And in fact, in terms of the syntax or format, how you write tuples, the parentheses aren't really needed. You just need to separate your values by commas. And if it's a single value, trail it with a comma. So the parentheses are there for us to help us understand we're looking at a tuple. The parentheses would be required in some instances, such as if you're trying to pass a tuple as an argument for a function's parameter, just because typical function parameters are enclosed within parentheses separated by commas. So just to clear up kind of why are parentheses and commas being used, you would need to add in extra parentheses if a tuple was going to be the argument for one of your functions. So even though you cannot alter or edit an item, a single element of the tuple of that sequence, you definitely can read, kind of look up that element, and you do so the same way we did for lists, same way we would do for strings. And that's using square brackets and an index locating integer after the variable name. So if your tuple had 5 items, each is just a single letter from the alphabet, if you look up the one that's in the 0th index position, it's going to be lowercase a. And you can slice it in the same way too, where within those square brackets, you have a start location, a colon, start location, a colon, and then a stop. And that stop is the index location, but not inclusive. So it's starting at 1, going to 2, and not quite going to 3. So you get the letters B and C. If you want to assign multiple values to multiple variables, you can do that very efficiently on a single line with tuples. So here you have a tuple 1, 2, 3. You can assign those values to another tuple. Here the variable names x, y, z, separated by commas. And after this assignment statement, both 1 is going to be assigned to the variable x and 3 will be assigned to the variable z. Here's just an example of if you had 2 tuples and you needed to swap the values in it, how you can do so with use of a temporary variable that will kind of contain the values in one of the tuples, but not actually ever be accessed past that point. Tuples allow you to return multiple values from a function. So here at the top is a function called swap, takes two parameters, x and y, and what it returns is simply x and y in a different order. That's a two-item tuple, y and x. So here is just kind of the code in action, and kind of pause and look how B and A and B can get swapped out. And there are kind of three print statements here, these printing on two lines, and so the output here in blue is the 5 lines. Another example right here, where one of the values is an integer. So of the three data types that are compound, we've learned about strings, lists, and tuples. All are sequences. Integers and floating point numbers are not. They're other data types. So what are the differences between them? Namely, strings are sequences of single characters. Could be numbers, letters, punctuation, enclosed in quotes. Could be single quote, could be double quote, as long as it's the same type at the front and end. Lists are enclosed in brackets, sequences of items separated by commas, and the item can actually be any type of data. It could be an integer here. One difference between strings and lists items can be changed, like I just did manually, using Python code. So you could say list bracket 1, which is the number 1 index location, equals the number 2. Strings, you cannot simply edit out a single character. Tuples are similar to lists in that they're sequences of items that can be of any data type, can be of different data types. Unlike lists, you cannot simply change that. Cannot do that. They're immutable like strings. There's also the syntax difference. So lists enclosed by square brackets. Tuples are by convention enclosed by rounded parentheses, but they don't actually have to be, unless you're trying to pass them as arguments to a function. So why the difference? Why are tuples a thing in Python, a basic built-in data structure? Basically due to memory management. So being mutable costs more memory. The lists take up more computing resources than would tuples. And so if you have, just the first 5 letters of the alphabet, the difference isn't going to be really consequential. But if you have lists of thousands or tens of thousands, millions of records, that difference in memory can be pretty substantial and can make the difference between whether or not a process can be executed or not on a given setup. So one thing mentioned here, tuples often conceptually useful if you think of each entry as a cohesive unit. So tuples are immutable. You can't edit or swap in and out single values. So think of them as a sequence that's taken all together. One good example of this, again, it's by convention. It's not the only way you can do things, but it's a useful way that things are done. So range 10 outputs a 10-item list of each integer from starting at 0 up to but not including 10. So this is an example of a homogeneous sequence. So they're all numbers, all the same type, have all the same meaning. And in Python, by convention, this kind of sequence is a list, even if you're not going to swap in and out something. Now this above example from the time library, so time.local time would output a tuple with multiple items here. What is it, 9? And each of these, you can kind of see, it has to do with the local time, the year, the month, the day, the hour, the minute, the seconds, even I guess the milliseconds. So each entry in that tuple means a different thing. And together, when interpreted, they give you a different local time. And so if you're interpreting that data object, it makes sense to do so as a sequence of numbers that each communicate different things. And so we call it heterogeneous. And again, that's just by convention. You could have a kind of a local time function that would output the information as a list. It would still work.